Bismillahirrahmanirrahim. Dear students, here we have example. Prove that the set of all rational numbers of the type 2 power a 3 power b, where the exponent a, b are integers, is a group with respect to multiplication of rationals. Here, the given set is denoted by G, whose elements are x such that x is equal to 2 power a 3 power b, where a and b are integers. So we will check the closure property first. For this, we will take any two element x is equal to this and y is equal to this, and the exponent a, b, c, d will be integer. Now we have to find the product of x and y by putting the value and simplifying the exponent. Here 2 power a and 2 power c will be written together. Similarly, 3 power b, 3 power d will be written here. Now adding the exponent here, similarly adding the exponent here. This is the simplification. This is an element of the form this one, hence this belongs to G. Here we see that if we take any two element x and y from G, and if we multiply both the element x and y, we see that the product also belongs to G. Thus G is closed under multiplication. Now we check associative law. In associative law, we take three elements. This is the first element, this is the second element, and this is the third element. In these elements of set G, the exponent from A up to F, all these exponents belong to Z. Now taking the associative property, this is the associative, this will give us associative property by putting value of x, y, z. Here we see the values. Now simplifying, first of all we will simplify this bracket. यहाँ पे 2 पावर c है, 2 पावर e है, इन दोनों को हम साथ साथ लिखेंगे. इसी तरह 3 को हम साथ साथ लिखेंगे. 2 का एक्सपोनेंट हम ऐड करेंगे, इसी तरह 3 का एक्सपोनेंट ऐड करेंगे. अब यहाँ पे हमारे पास क्या है, सिम्प्लिफिकेशन है, तो 2 के साथ हम इसी 2 को साथ में लिखेंगे. Similarly we will write 3 and this 3 together. Now adding the exponent of 2 and exponent of 3, so this is the simplification. This is the value of x into yz. Similarly the product xy into z, if we put the value of xyz and if we simplify, we will get this value. Here the value in the right hand side are equal, hence the left hand side will also be equal. This is the associative law of multiplication for all x, y, z belong to G. This associative law holds in set G. Now we check the identity element, that is multiplicative identity element. Let x is equal to this. In G there is 1 which is equal to 2 power 0, 3 power 0 in G, such that the product of x and 1. Here we will find the product of x and 1 by putting the value and simplifying. We get 2 power a 3 power b is equal to x. Here the value is x. Similarly, if we take 1 into x by putting the value and simplifying, we get again x. Here the right hand side are equal, hence the left hand side will also be equal. Thus x dot 1 is equal to 1 dot x. This is the this shows that 1 is the multiplicative identity element. That is, if we multiply any element of set G by 1, we get those elements again. Thus G possesses identity element 1 in G. Existence of inverse. For each x in G, there is y in G such that x into y is equal to 1 and it is also equal to y into x. यहाँ पे ए बी क्या है, ए बी आर इंटीजर्स और माइनस ए माइनस बी क्या है, ये भी इंटीजर्स है. दिस इज फर्स्ट एलिमेंट ऑफ जी, this is another element of G. If we multiply x and y, we will get 1. It means that every element of set G have multiplicative inverse. So the property exists of inverse holds for set G with respect to multiplication. Thus G possesses 2 power minus a, 3 power minus b as the inverse of this in G. Hence, G together with multiplication is a group. Let R2 be a set of matrices of this form where the entries A, B, C, D are real and the product AD minus BC is not equal to 0. If we look AD minus BC not equal to 0, it means the determinant ABCD is not equal to 0. अगर इसी मैट्रिक्स का हम डिटरमिनेंट मालूम कर ले तो वो नॉन जीरो होगा, या हम कह सकते हैं कि दिस मैट्रिक्स इज नॉन सिंगुलर. तो ये हमारे पास क्या है, दिस इज द प्रॉब्लम. लेट R2 बी अ सेट ऑफ मैट्रिसेस ऑफ दिस फॉर्म वेयर दीज एलिमेंट्स आर रियल and AD minus BC is not equal to 0. Prove that R2 is a group under matrix multiplication. So let us check closure property for element AB and R2 such that let A is equal to this one and B is equal to this one. Here the product A1 D1 minus D1 C1 will not be 0. That is, A determinant will be not 0. Similarly, B determinant will not be 0, and we have to prove that AB determinant is not equal to 0. अगर इन दोनों का हम प्रोडक्ट मालूम कर ले तो ये वाला मैट्रिक्स R2 में बिलोंग करेगा क्योंकि इसका डिटरमिनेंट नॉन जीरो है. सो क्लोजर प्रॉपर्टी यहाँ पे एग्जिस्ट कर रहा है, यानी अगर हम R2 से कोई से दो नॉन सिंगुलर मैट्रिसेस ले ले और अगर इनको हम मल्टीप्लाई करें तो इससे हमें नॉन सिंगुलर मैट्रिक्स मिलता है. लिहाजा R2 क्या है, R2 इज क्लोज अंडर मल्टीप्लिकेशन. इस तरह एसोसिएटिव लॉ अगर हम R2 से कोई से 3 एलिमेंट्स ले लें तो इसमें एसोसिएटिव लॉ एग्जिस्ट करता है. और आइडेंटिटी इसमें क्या है, दिस मैट्रिक्स बिलोंग टू R2 and this is the identity matrix in the given set. This X is a multiplicative identity because if we multiply A with I and if we multiply I with A we get A, hence I is equal to 1 0 0 1. That is, this identity matrix behaves as a multiplicative identity for the set R2. Existence of inverse. A inverse exists because A determinant is not equal to 0 and belong to R2. R2 में जितने भी मैट्रिसेस है वो सारे नॉन सिंगुलर मैट्रिसेस है, यानी उन तमाम मैट्रिसेस का डिटरमिनेंट नॉन जीरो होगा. R2 में जितने भी मैट्रिसेस है उन सब का डिटरमिनेंट नॉट इक्वल टू 0 होगा. जब कभी किसी मैट्रिक्स का डिटरमिनेंट नॉट इक्वल टू 0 होगा तो उसका A इनवर्स एग्जिस्ट करता है. So A inverse exists because A determinant is not equal to 0 and this will belong to R2. Hence R2 is a group under multiplication.